Hi everyone, my name is Ting Pan and I'm from Borno University of Technology. The topic of my presentation is Environment Footprint Assessment of Building Energy Management System. Here is the outline of the presentation. Firstly, I will begin with the introduction of my research. According to REA, more than half of the annual energy consumption in households is due to space heating and air conditioning. Especially in Europe, it accounts for a staggering 79% of all energy consumed by users. Additionally, 75% of the energy used for this purpose is produced from fossil fuels. The proportion is alarmingly high. To combat this, electrically driven heat pumps represent a solution that can increase the share of electrification and renewable energy in buildings, which is also the process of decarbonization. So, we propose a RESHeat system. The system is proposed by the collaboration of multiple institutions shown in the picture. The goal of the project is to develop and apply a new, innovative, renewable energy system. The system aims to address at least 70% of the total annual energy demand in multi-family residential buildings. It could provide the real performance of innovative, renewable, and energy-efficient solutions, including heating, cooling, and domestic hot water. In addition to efficiency, we take sustainability into account. Therefore, 3 demonstrations are built in Poland and Italy to test the effectiveness of the integrated systems. Before we tell the design of the system for Poland and Italy, we need to investigate the energy structure of the Italy and Poland. The upper left figures show the electricity mix of Italy. It shows that the fossil gas accounts for 51% of the electricity mix in 2021 in Italy. The condition of Poland is even more critical as shown in upper right figure. 79% of it is in Poland, placing it top of the Europe. Additionally, 69% of the power is from coal. It shows the urgency to improve the utilization rate of the renewable energy. Solar energy is an abundant and accessible source of renewable energy. The 2 countries show different levels of solar radiation. In the first half of 2022, Poland was 3rd in Europe for solar capacity installations, and the heat pump sales also boomed in Poland last year. In Italy, from the perspective of the solar sustainability, it varies from 46, very low sustainability, to 99, the highest value, which depends on the seasons. Therefore, we firstly attempt to design and apply the demonstration in Poland. The calculated technical potential of photovoltaics in Poland is 153 petajoules, which could cover 26% of Poland's electricity needs, while the current share is only about 4%, and the coal purchase out is scheduled for 2049, just behind the timeline to keep 1.5 degrees centigrade. For 2022 solar capacity additions, Poland is one of the top 5 countries in Europe. The RESHeat system is proposed to make full use of renewable energy on combined cooling, heating, and power as shown in Figure 1. Solar energy is the main source of electricity and thermal energy. Photovoltaics and PVT panels are installed to generate electricity for the heat pump and other facilities, with the grid serving as backup power storage. The lower temperature thermal heating produced by PVT is stored in the borehole heat exchanger and will be reused during the winter to improve the coefficient of performance of the heat pump. The average annual COP of heat pumps is higher than 4.8. The thermal energy generated by solar collectors is stored in the buffer, and the excess heat will be stored in an underground heat storage tank and used during the heat season. The cooling demand is satisfied by the heat pump in summer. As a new system, RESHeat system is currently in the prototype demonstration. It's imperative to evaluate its environmental impact thoroughly to enable a fair assessment of its potential for emission reduction on a life cycle basis. The case study is adapted in a building in Limanowa, Poland, which consists of 9 multi-family apartments. To evaluate the environmental impacts of the system, the OpenLCA software and the eco-event database are used. The assessment method utilized was a RESHeat 2069 midpointage, with a lifetime assumption of 25 years for the RESHeat system. The energy demands of this building are shown in the table. In the life cycle assessment of the system boundary is defined as material, operation, and end-of-life stage. The function unit is defined as the electricity, thermal, and cooling energy generated by the building energy system for 1 year. When considering about the environmental impacts, the greenhouse gas emission and water footprint are analyzed. What's more, this study provides an improvement assist in the end-of-life stage. Compared with previous studies, more disposal ways are explored, including the landfill, recycle, and reuse, because there are huge materials installed in the system, especially metal, which could be reused in the next life cycle. The life cycle inventory of the system is shown in the table. The gas boiler system is also analyzed as benchmark. The results present. The system has shown significant reductions in environmental impacts, with about 80% lower total greenhouse gas emissions and 70% less water consumption. It gets rid of the reliance on natural gas, contributing to reducing the carbon emissions. Especially, it can be seen that the material stage is the main driver for the carbon emissions. Let's explore further. Steel accounts for 87.85% of the total emissions by material. Therefore, the storage tank and the hydraulic system are most responsible for the carbon emissions. Hence, we believe that refining the material utilization by attempting recycling and reusing can further diminish the system's environmental impact. Let's see other share of environmental impacts of such solar combined cooling, heating, and power system. The left figure shows the total environmental impacts of the system, including the grid electricity consumption. It shows that the grid electricity consumption accounts for almost 80% of the total impacts, indicating the highest emissions from the operation stage. When removing the operation stage, the photovoltaic are responsible for 58% of the greenhouse gas emissions. When comparing the solar combined cooling, heating, and power system with the grid-based system, the HCC-HP system showed only half the environmental impact of the grid-based system and reduced the environmental impacts more than a conventional photovoltaic system, showing great advantage of such integrated systems. In conclusion, the RESHeat system exhibited 8% lower total greenhouse gas emissions, largely due to its renewable energy utilization, which fulfilled 100% of a household's energy electricity amount. We will move forward to compare the RESHeat system to other similar solar energy systems in the future. And the initial carbon emissions are higher for the RESHeat system, primarily because of steel usage in installation process. Recycling and reusing materials could reduce the system environmental impact considerably. The research has been supported by the RESHeat project, which received the funding from the Horizon 2022 research. That's all. Thanks for your attention. We will also organize the 7th September Process Integration Laboratory Scientific Conference in conjunction with RESHeat workshop from the 1st to 3rd of November in Czech Republic. Looking forward to your presence. Thank you.